So today we are going to be discussing segment bisectors. Luckily you have a little bit of a head start on these because we did angle bisectors in class today, so I'd imagine it would be pretty easy in that sense. At least you know what those angle bisectors are. Again, tonight you're going to be submitting your WISC form, your Watch, Summarize, and Question form through Schoology. So again, make sure you log into Schoology. I can reset your password if you forgot it. But I would also want you to take notes on a separate sheet of paper. So you're not basically turning in your notes, you're taking notes on a separate sheet, so that way when you come to class tomorrow, you're ready to go with our segment bisector notes so we can jump right into answering some questions that you have. So we're going to start with some definitions first. So there are several main key terms here, and I'm going to see if I can select these and move them up. There we go. Okay, so there are several main key terms that we want to look at. Notice one of them, bisect, we did today in class. So you should be able to do that already. Let's go ahead and start with that one. And again, basically it means to cut into two equal parts. And I'm going to get a new stylus. My handwriting with that one is not too great. I don't know if it'll even help with the new one. But again, our bisect is to cut into two equal parts. So when we look at midpoint now, that's a little better. A midpoint is a point that divides, or bisects if you want to say it, a segment into two congruent segments. So again, it's going to divide a segment into two parts. Okay. Now again, we've already done the bisector. So bisectors usually we say with angles. Midpoints we usually want to say with segments. But we can still say, again, we could kind of still say that this is a segment bisector, or the midpoint, kind of the same thing. So a segment bisector then, if you can see the segment bisector down here at the bottom, this could be another segment, array, or even a line, okay, that intersects a segment at its midpoint. So that intersects a segment. And we'll look at some examples here in a second. At its, I'm running out of room there, perfect, at its midpoint. Okay. So if you need to pause it and write some of these vocabulary words down, again, it's going to be something that we've seen already, but we're just taking it a little step further now. So let's try some examples. Notice I have 3 examples. If you want to try these on your own, then go ahead and pause this video right now. Also, if you want to take some notes on this, probably not a bad idea to pause and pick some of these up in just a second. So again, notice in our directions here, M is the midpoint. We want to find the length of TM for the first one and MR. So again, for the first one, if we notice M is at our midpoint, we just divide it, this whole thing, right in 2. So then it makes sense that both these segments are going to be equal in length. Again, that's our midpoint. It's also technically not a segment bisector. A segment bisector, I'll just draw over this. Again, is going to look basically, if a line cut that in half, then we can see that's 7, that's 7. So as of right now, it's just a midpoint. So then the next one, again, very similar. We want to find the length of segment FM and segment MD. Again, we know this whole length here is 36. This is our midpoint, so we want to chop it right down the middle. So the length of these both is 18. Last one, slightly different, not really any more difficult, but so you kind of get the idea. So we want to find 2 lengths, segment MR, segment QR. Again, we can see QM is 5. We do have those little congruent marks here to show that QM and MR are the same length. So MR is also 5. Now QR, again, is the whole thing. So 5 and 5 would just be 10. Okay, so now we have one involving a variable. So again, we want to find each of the segment lengths. Now we already know MB is 18. That's given to us here. we also know that MB and AM are congruent. They have the same measurements because, again, we know that this is our midpoint already. So what we need to do is, again, set up an equation. We know that AM has a length of 2x, MB has a length of 18. So again, it's just a one-step equation now. Divide by 2. Our value for our variable is x. Oops, I wrote the wrong number in there. Did not mean to do that. Let's get my eraser here. Okay, so again, we have that should be equal to 9. I don't know what I was doing there. Okay. So now to go back in, again, we can see that AM obviously would be 18 anyway, so we don't even really technically need to solve for that variable, but I wanted you to just see how we did it. Okay. Now the length of the entire thing is 18 and 18, which is equal to 36. And again, that would be AB. Okay, and that's what we were asked to do. Find this, find this. Again, didn't really need to solve for the variable in that one. As long as we could see this is 18, that's obviously going to be 18, 18 and 18 is 36. But again, just wanted you to know this piece here of what that looks like setting up an equation. Okay, so let's go ahead and try this one. Again, this one we would need to actually solve to figure out the length of AM, the length of MC, so that way we could find the length of those, and we could also find, again, AC out of that as well. So again, based on this, we know that this is a midpoint, not because we're told, but now we can see we have M here. It won't always be M, but we do know this piece here, that mark and this mark indicate those two segments are the same length. This distance and this distance is the same. So just because of that information, we know, again, that AM is the same as MC. I should put congruent too. So therefore, x plus 20 is equal to 5x minus 4. And my phone's ringing, so let me pause. Okay, so we'll go ahead and pick up where we left off. And again, this is a 5x minus 4. So now again, we want to combine our like terms. Nothing to combine on the left side or the right side, so we can go ahead and just start subtracting. So I'm going to subtract this x to both sides. So on the left, we're left with 20. On the right side, 4x, subtract 4. So let's go ahead and add 4 to both sides now. So 4x equals, bring our equal sign down, 24. Divide both sides by 4. Come on, pen. And x has a value of 6. But again, remember our whole purpose of doing that wasn't just to find the value of the variable. We want to plug in. So we want to find the length of AM was x plus 20. Well, we know that x was 6, so basically again we're going to take that 6 plus 20, AM is equal to 26. So there's one of our answers. Now we also want to find the length of AC. Now you could plug it back in, but that's not even necessary. If we know that AM is 26, then MC should also be 26. We add those two together for the whole thing. AC should equal 52. And again, we don't know what units we're in. It could be feet, yards, meters. We don't really know, so we'll just write 52 for now. So now we are going to have line L bisecting segment PQ. So let me go ahead and put in segment PQ here. This could be just a segment, could be part of a line segment. I'm just going to put it here as a segment at point R. So my drawing is not going to be exact to scale, but we're going to have line L here. I'll go ahead and put in line L. Let's say it bisects at that point. Again, that's going to be point R here where it's bisecting. In other words, that's the midpoint now, so these pieces are even. We want to find the length of RQ, this piece here, if PQ is equal to 14. And again, the math on it is not really what's most important right now. I know it sounds kind of weird. What's most important is that you can interpret what this statement is saying. But basically, again, if we can see that now this whole thing is 14 units long, again, we're going to take half, so RQ would just be 7. Again, just interpreting what, number one, the symbols mean, and number two, what the terminology as well. So last problem, I want you to go ahead and take a look at this diagram. This is our last thing we'll do today. Notice we have this figure where basically these two segments are bisecting one another, creating equal segments. And you can see all those marks indicate, for example, AM is congruent to MB. TM congruent to MQ. Okay, so and we have the first part. I'm just going to go ahead and write it right on our diagram here. Segment TM is equal to 3x plus 5. So this one here, 3x plus 5. MQ, x plus 17. And we're told just to find the value of x. We won't even plug in right now. Okay, just find the value of x. Again, we know they're equal. So again, all I want you to do is to show me mathematically what it means to be equal. And really, it's just showing those two are equal. So again, we'll subtract x on both sides. Let's go ahead and solve. So 2x plus 5 equals 17. Okay, subtract 5 on both sides. So let me put it over here. 2x equals 14. And again, x is just equal to 7 after we divide. Okay. Again, I'll let you go and try the last one. Again, if you want to pause it, that's fine. I'll go ahead and do it though. So 5y minus 1 equals, now this one's a little different. Okay, so this piece is 5y minus 1. MB, we don't know. However, we know we have two that are the same. So what I'm going to do is 5y minus 1 plus 5y minus 1 equals the length of the entire thing, which is 38. Okay, so let's go ahead and combine 5y. 5y is 10y. Negative 1 and negative 1 is a negative 2 equals 38. Add 2 to both sides. So 10y equals 40. And again, after we divide both sides by 10, y has a value of 4. And there's our completed problem from this one. So again, go and fill out your WISC form. I know it's a little longer today, about 12-minute video, but go and fill it out, reflect on it, bring your notes back tomorrow, and we'll practice. Have a good night.